Good morning, one and all. On behalf of Janata Education Society, Vivekananda Institute of Technology, I, Arpitati, Assistant Professor, Department of CSE, take this opportunity to welcome you all to our today's webinar on DevOps. Today we have with us Mr. Adarsh Mehrotra, Industry Principal Consultant at Infosys. Welcome you, sir.
Thank you.
Let me introduce Mr. Adarsh Mehrotra. He has 16 plus years of experience in the IT industry and is currently serving as industry principal consultant at Infosys. He started his career as .NET developer and moved to the field of application lifecycle management. Later, he worked as DevOps consultant and SRE and led many large-scale DevOps and agile transformations for various clients across the globe. Adarsh continues to build service offerings and accelerators in the area of DevOps to expedite the client journey on adoption. On behalf of everyone from the VKIT, I once again welcome you, sir.
Thank you. Thanks a lot. So thanks for giving me the opportunity, first of all, to interact with you guys. And it's always a very novel experience interacting with the younger students. You feel a lot more energetic. You feel a lot more energy. So thanks for that opportunity. And what I wanted to cover today is give you guys a brief glimpse of what DevOps is all about. And I wanted to bring in some industry experience into the conversations because sooner or later you guys are going to join the industry. So we will cover more practical aspects from industry on how some of these technologies are evolving, how some of these technologies are shaping the way enterprises have worked today. So we will cover a lot of these practical aspects. More than happy to take up the questions. So what we will do is we will get going on this. Let's start. So let me know when you guys are able to see the screen. We will get going on this. Let's start. Let me know. So are you able to see the screen now?
Yes, sir.
Hi, is it all visible now?
Yes, sir.
Okay, excellent. So apologies because of the current situation. There are frequent internet outages and things like that, so I apologize. Let's get going.
Sure,
So I'll quickly share my
yeah,
screen, and I hope it is visible now. Are you guys able to see the screen now?
yeah, sir. It's visible.
Yes, sir.
Okay, brilliant. Okay, so what we will do is I have divided the current conversation into 5 areas. First is we gave a current view from the enterprise, which is I just wanted to bring a bit of an industry experience on how the enterprises are shaping up today. What are the key trends that are going in the industry? What are the big buzzwords that you guys should be looking at? Then we will cover a bit of a why on DevOps. So what are the key characteristics of or levers because of which there is a mass scale adoption of DevOps in the industry? Then we will cover the what of DevOps, which is very important. What constitutes DevOps? What are the main pillars of DevOps, and how does the life cycle evolve? What are the kind of tools and the processes that we should be aware of? Then we will cover the how of DevOps, and this is again very crucial part on how DevOps gets executed within the enterprises. Again, we will cover some of the key constituents, some of the success factors, and things like that. And then we will talk about finally, because you guys at sooner or later stage are going to enter the enterprises and work for corporations. How are the enterprises running DevOps today within their organizations, and what constitutes success for them? Because it is very important at the end of the day that there are critical success measures that come out of it, and every organization at the end of the day wants to uh, create profit for themselves. So what is it from a DevOps lens that excites them? We will cover some of that from an enterprise DevOps lens. And then finally, the last topic will be for people who are looking at DevOps as a serious career option. How do you build this capability? So from your individual perspective, what is in it for you? And I hope that these 5 or 6 constituents will be giving you enough insights to take a pulse of what DevOps is all about. Okay, great. So let me move ahead. Let's start with the current view of the enterprises. And these are some big names that you see in the industries, right? So the slide says, why do enterprises need to transform? You would have seen of late that there are many organizations that were within Fortune 500 list maybe 10 years back. Not a lot of them exist today. There are a lot of these big names like Google, Netflix, Amazon, and they're ruling the market. So what is that key underlying theme that these guys have taken, because of which they're really spearheading the movement within the enterprise agility world? So you see there, the last one, that is a very critical factor: annual software releases. What it means is that the number of times the services from these organizations hitting production is just immense. They are deploying 1,000 times a day, more than 1,000 times a day in a lot of such cases. And what it means is that the enterprises that are wanting to move at a faster speed, those are the ones that attract the maximum eyeballs because they get a very quick feedback from the industry. So today, for example, I release a feature and I get a very quick feedback from our end customers that whether it is working well or it is not working, and then I can pivot my ways through. So I can always say that if it is not working well, all right, let's move ahead with something else and quickly release it again and get a quick customer feedback. If it works well, then I expand on it. So all of these organizations have made sure that they move with a very, very fast speed. And how do you get that fast speed? The more number of times you deploy to production. So from an enterprise level, bringing the nimbleness and the agility is extremely important. And that is what will make sure that these organizations not only survive, but they thrive. Now, let's take some salient, cases in all these, in all, some of these organizations. So say something like Google. I mean, Google is running millions of automated tests, and we don't even realize when we start consuming their services. And all of these tests so in 2017, the stats was that Google was running close to 4.2 million tests, and almost all of them automated. And only 2% of them were flaky tests. Flaky tests means that they showed some kind of instability, and that's a big number. So you see the kind of best practices that these organizations have built over time that have made sure that they move with a lot of speed. Netflix, for example. So Netflix, you guys would have watched a lot of movies on Netflix, right? A lot of serials. And so what happens is Netflix wanted to give a seamless experience when it comes to watching the videos. And for that, they created certain tools on stress testing, which again I believe you guys would have heard of it. If not, then I would highly recommend go and read through it. Something called as a simian army. So what these tests would do is they will actually go into the production and they'll make sure they test whether the production was running fine or not. So before even the end customer could feel the pulse that things are slowing down or the performance is not happening, Netflix would actually fix some of these things much early than the end customer would discover a bug or a fault. Similarly, Amazon. I mean, Amazon has been a pioneer in the space of agility. They in way back in 2011 when they started adopting on AWS. At that time, they were deploying 11.6 seconds. One production deployment hitting 11.6 seconds. So you can imagine that these organizations today have made sure that they deliver at a very fast pace, and they've made sure that at an enterprise level, they have brought in agility. And it is not only about the tools, but they've also introduced the best practices across 4 dimensions. And these 4 dimensions will keep on resonating in this next 1 hour. They made sure that they've equipped their people. So people is one very important dimension. They made sure that they have the right processes in place. So process is the second important dimension. Third important dimension is tooling, that I'm sure a lot of you guys use tools and you understand what those tools are. And the fourth important part is culture. So these are the 4 pillars, which kind of, if you do good in all these 4 areas, that is helps you in achieving a lot of nimbleness and enterprise agility. So let's move ahead, and I'll want, keeping on with the same view of enterprise agility, let's take a few scenarios. So what do we see in the market today? So every business is a digital business. I'm sure you guys would keep hearing a lot about the word digital, right? So what it essentially means is that the end user is empowered today to take a look at the services on his mobile and respond to it, or on the iPads and things like that. So it's a very quick and the faster medium where you can get response. Similarly, the customer is very savvy today. So if there is a poor experience, it just spreads the bad vibes all across. And you can give a quick feedback. I've seen people going on mouthshut.com and websites like that and share their poor experience, and then it creates a lot of bad vibes for the organization. So let's keep in mind that today the customer is very savvy. They are very equipped. They have the information at the click of a button, and hence experience is going to be a very, very important theme for all organizations. Production incidents cost a lot. So any incident that happens in production is just takes an enormous amount of time, energy, and money for organizations. I don't know how many of you guys recollect, but in 2017, British Airways, they had a software glitch, and close to 75,000 people got stranded. And as a result of which, British Airways had to incur a fine of 80 million pounds. And that is just a staggering amount. So you can see today we want to make sure that while we move faster and deploy many, many times into production, at the same times we have to be stable enough, and we don't want production or incidents or severity 1 incidents happening in production, because again, it ruins the organizations. And of course, we've talked about it, that you need to respond a lot quickly and realize your value faster. What it means is that as soon as you figure out that certain things are working or not working for you, you are ready to adapt to the change and move a lot faster. In fact, I'm sure a lot of you guys would have heard of this famous quote from Charles Darwin that it is not the strongest of the species that is going to survive. It is a species that is most adaptable to change, and that is the species that is going to survive. Okay, so the objective of bringing some of these aspects was that in a lot of enterprises today, they want to move a lot faster. At the same time, they want to be a lot stable in production, and they want to save the costs as well. So enterprise agility is one of the biggest themes with a lot of enterprises today. Okay, So I'll move to the next slide. And again, you will keep hearing about a lot of these words, whether you read the newspapers or you read the blogs. And I'll take few liners to explain now, but we will cover this in the due course of the presentation. So organizations today are looking at enterprise scale adoption. What it means is that they, in some bits and pockets, they may be doing very good work on automation, or they may be adopting very healthy practices, but it is not at a very large scale. So it has to run as a factory model where they, just like you would have seen the case of Toyota, right? So they introduced a factory model where everything was so automated and so perfect that they could manufacture more number of cars. So the enterprises are looking for enterprise scale adoption of some of these practices. Then culture changes. This is extremely important again, because what happens is that while you may introduce the best of the breed tooling, but let's say, how do you change the mindset of the people? So there are people in the organization who are sitting for say around 20 years, 25 years, and it is very difficult to bring about a change in the way they think, a change in the way they adopt, and the way they write code and things like that. So cultural aspect is a very, very important aspect. Uh, Cloud agnostic DevOps. Again, this is something that you may keep hearing about, and I would encourage that you read through this more. So we have number of cloud vendors now, and especially with the given COVID situation, you would be seeing that there is a large scale adoption of cloud, because everybody wants to be on cloud, make sure that they utilize the native services, because they don't want to maintain and manage. People cannot move into the offices and things like that, and hence it's easier to make a movement to cloud. So AWS or Google Cloud Platform, or certain other vendors, Azure, Microsoft Azure, these have gained a lot of importance. But from an industry perspective, the organizations don't want to get locked down with, say, a vendor X or a vendor Y. At some point of time, when they realize that either the services are not working well for them, or cost is a prohibition, they may want to move out of one vendor to the other. And that is all cloud agnostic DevOps. So again, I would encourage you to read through a lot, because cloud technologies, they are the future. In fact, they are the present rather. And I would highly encourage you guys to look through some of the existing patterns on how you can build a cloud agnostic approach. There are a lot of tools in the market, like Terraform, that help you in building something like that. And again, it involves a bit of a process layer as well. The fourth aspect is microservices, and I'm sure you guys would have heard of this term microservices quite often. Microservice essentially is, so you take a big application, break it down into smaller services that are independently deployable to production, and each service will have its own database. So the objective is that we do not want one big monolith going and hitting production, because again, it takes a lot of time to correct things in that case. So we are looking forward to chip away the debt from our existing monolithic applications and making sure that we migrate them to microservices architecture. Again, a very important and a key theme that will continue to exist in the IT industry for quite a long time. So again, I would highly encourage you guys to start looking at some of the microservices, how you build them, what are the key design patterns on microservices. Then there is a platform-based approach, and what it essentially means is that within the industry, we don't want every time setting up a team that helps in stitching some of these tools together and giving us an end-to-end view on how requirements flow all the way till production. There should be a robust platform, and these should be self-service platforms. It should be as simple as, say, for example, you have an ATM card, you get an authentication mechanism, you go and withdraw your cash, and that's it, end of the story. So from a team perspective, it should be something as simple as, if you are wanting to deploy to production, there is already a bunch of tools available, there is already a process layer on top of it, and you just have to commit your code base, and after a number of checks and tests that get performed, there are certain gated mechanisms that come into picture. Things will go and deploy to production. So you need a robust platform to support something like that. Then continuous testing. I'm sure some of you guys would have heard this term. But continuous testing means that rather than testing your code at the end of the SDLC or the software development life cycle, we test it a lot earlier in the life cycle. Because remember that when you fix a bug that is caused in production, that is a lot more costlier than when you fix it very early into the life cycle. So there are a lot of concepts today. In fact, when you guys practice coding, I would highly encourage that you go ahead and practice something like a test-driven development. These are some practices that have picked up in last few years, where you are actually writing a test first before the code, and then you write the code, and then finally you write the test that passes that code, and then you refactor your test cases. So I don't want to get into the depths of it, but the idea is that as soon as you write your code, it gets tested. It gets tested a lot early. That's the idea. And when I say testing, I'm not only talking about unit tests, but we are also talking about regression tests, performance tests, load tests, stress tests. So there are various stages in your software life cycle when you have to test it and bring them early into the life cycle. That's the idea. Then open source adoption. I'm sure you guys utilize a lot of open source tools. I'm sure you would have heard of a lot of these tools in various spheres. For example, I personally use this software called Audacity a lot for the audio mixing and stuff like that. I'm sure you would have heard of tools like Drupal and also very, very popular tools in the market, Notepad++. So within the industry also, there is a very healthy adoption rate for open source tools. One, because they save the cost, and second, you don't get tied down to particular vendors. And of course, from a security perspective, you have to keep certain things in mind when you start utilizing open source tools. So this is again a big trend within the industry to move towards open source. And the last one, last but not the least, and very, very important, especially for people who are maybe passing out in a year or two. So you will keep hearing a lot about site reliability engineers requirements. And essentially, this term has come from Google. This is something that I'm sure a lot of you guys would have already read. And if not, go and read the book from Google on site reliability engineering. So the objective is that um, you are looking at the stability of things. So one is speed. You do deployments very quickly into production, but at the same times you have to be resilient enough in production, which means that you have to look for the services that you have deployed into production. What is their availability? Are they reliable enough? Are they not carrying vulnerabilities? You have to look through aspects of their performance, whether the page is loading at the right time that you promised to your end customer. So some of these aspects, the operational aspects, get covered under site reliability engineering, and this is something that is becoming very important as we move more towards the cloud adoption. So believe me, site reliability engineers, there are very few in the market, and they are highly paid. Okay, all right. So why am I telling some of these areas? Because at the end of the day, the organizations are looking at three things. They are looking at speed, which we talked about. So how quickly you deploy things to production. They are looking at resilience in production. So it should not happen that the more you're deploying to production, production keeps getting broken often. So you need stability in production. And third, they want to optimize their costs. And DevOps is one such lever that helps them deliver faster. So it provides the speed. It helps them deliver with a lot more quality. And we will talk about how we bring more quality into the work that we deliver to production. And third is, of course, the cost. So you utilize a number of levers to make sure that you create a cost-effective solution, and you remove a lot of manual propensity that gives you errors. So hence the need to bring in DevOps. So DevOps is one such lever within the organizations that helps them achieve all these three, right? So you move at a faster speed, you bring in enough quality in what you create, and you help in reducing the cost. So what we have done so far is we have seen the common trends in the industry. We have seen why agility within the enterprises is a very important theme. And to bring that agility, you need something like DevOps. So we've established why we need DevOps. And so I hope at this point, we have firmly established the need to get into DevOps. Now let's talk about what DevOps is all about. So we've covered the why part of it. Now let's try and cover what DevOps is all about. So dev and ops, you've seen the two words, right? Development and operations. So both the words, when you combine them, it becomes DevOps. So DevOps essentially comprises of 4 pillars, and you can see all those 4 pillars that we've talked about. So we have talked about people, making sure that we equip the people, we make sure that the people understand that there is a shared responsibility and they are all working together as a team. Then processes, which are extremely important. So who are the right set of people? Are they doing the right set of job? What are the overall policies in terms of governance, and how they are reacting to certain situations? Then we talk about metrics, which is part of the process, and metrics means that how do you measure certain things. So for example, you may be a developer and you think you would have written a great code, but well, your code may actually have few vulnerabilities. For example, I'm pretty sure a lot of you guys would create login screens for some of the other modules that you would code in your day-to-day assignments. So have you looked at some of these patterns? Like, for example, people can exploit regexes, and those are some common vulnerabilities that we see. So have you taken care of some of these areas? You may have written a great code that you think, but when you run a vulnerability scanning tool over your code base, it shows you 1,000 errors, right? So metrics, very important measure, which is part of the process. Then culture. And culture, believe me, is one of the most important aspects out of all the 4, because what we are talking about is responsibility for the team to make sure that not only they code, but they are also deploying and they are also maintaining and managing. So the world has changed, where you had a lot of these teams that were only doing the development, then finally they were throwing everything to the testing team, and there used to be a separate testing team. Then the testing team would test and certify if things were okay. If the things were not okay, they would give it back to the development team. Then the development team will fix things again, and then the testing team approves it. Then they will throw all their code to the ops and then let the ops manage. That world is fading away really fast, and we will cover why it is fading fast and what are the new ways that are coming. But essentially, there are teams today that are not only developing their code but testing it by themselves and managing their whole code in within the production as well. So with that, the culture of trust, accountability, responsibility, that becomes very important for the team members. And then the final part is tooling, and of course I think a lot of you guys understand the tools. So we have version control tools. I'm sure you guys would have used some of them. People use the distributed version control tools a lot these days. We also had the centralized version control tools earlier, like SVN and all. But again, from a market perspective, people really do not put their code base in centralized version control systems unless it's really necessary. So version control systems, you have the continuous integration and continuous delivery tools, which I'll talk in a while. And again, configuration management, number of tools for monitoring you have and things like that. So the idea is that when I talk about DevOps, I am talking about all these 4 areas: the people, the process, the culture, and tooling. And if I understand all these 4 dimensions really well, and I work under this umbrella of the 4 pillars, it will result in faster development, frequent releases. So you release a lot faster to production. You get a very quick feedback because you are releasing with enough frequency. And do you get a lot of stability and resilience in your production because you have taken care of quality, security, performance much earlier in the life cycle. So this is in a nutshell is DevOps is all about: people, process, culture, and tooling. Now, I know it sounds a bit heavy at the moment. How can we ensure that a single person who is a DevOps specialist or a DevOps engineer follow all the 4? But yes, we will get to that. We will. I will explain how a DevOps engineer can actually be part of all the 4 and deliver, which will result in some of these areas. So some of you would have already heard or maybe even utilized tools like Jenkins and maybe Bamboo or some of our other CI tools. And And DevOps is not about tools alone. So let's be very, very clear. It is not about using Jenkins and creating a pipeline, or it is not about creating some automation, within your software development lifecycle. It is also not a silver bullet to everything. So you just cannot take a look at all the problems within an organization and say that, well, DevOps is going to solve your problem. DevOps will help in a very specific purpose where if you have a code base where you want to move very quickly things to production because you want to get a quicker feedback, in that case, you set up a DevOps process. And again, like I said, there is a very strong element of process there as well. You set up the right set of tools and the process in sync and in harmonization. You equip the people so that they hop onto that process and tools really quickly. And then you have a culture within your organization that supports and handholds each other. So if you have all these four aspects covered, that is what we call DevOps. So let's be very clear. It is not just about tooling. Okay, so this is a very important slide, and I don't know how many of you guys would have already heard some of these terms: Agile, DevOps, Waterfall. These are all so Waterfall and Agile. These are all software methodologies. What it means is that we utilize these to develop and build our code base and push things to production. So Waterfall, it has been existing for quite some time. It still exists, but I'm sure you guys would have heard that it is all about Agile today. So even a lot of conventional verticals like let's say an aero industry or a healthcare industry that were averse to Agile development have all started adopting Agile. And again, it's in waves. It happens with a certain frequency. So let's talk a bit about what these methodologies are. We talk about, say, for example, Waterfall. So what happened is within the Waterfall is that there were various phases. So you get requirements, you analyze your requirements. Then you create design for those requirements. Once the design is frozen and you get an approval, then you build on those requirements, which was a time when your development team would come into picture. Then you would write test cases on the code base, and then you will have a separate team that would test those requirements. Then you do a showcase with the business, and finally you do go ahead and then release things to production. And this would take a typically pretty long time. Then came the Agile methodology, Agile software development. And what essentially would happen is a lot of things would move in parallel. So you get the requirements, and also it's very important for us to realize the actors involved in these methodologies. So as you see in the Waterfall, you have the business, the dev, and ops together. In some cases, you will find that there is no element of ops coming in that first bracket that I'm showing, or the first column. So what happens when you talk about the Agile development is that when you get your requirements, you try to break those requirements down into smaller chunks or smaller areas of work, which we typically call as epics and user stories. And then you do a design, build, and test cycle in parallel. What it means is that you will make sure that you build your code and test your code within the sprint duration or within the duration where you can release something tangible. And then those small tangible bits is what you release to production. So what Agile development says is, instead of having a large or a big requirement that goes and hits production, say in 4 months of time, let's break that requirement down into smaller pieces, and each of those smaller pieces is fully testable, and hence they can hit production early, and I can get a quicker feedback on those elements. So what happened with Agile is that because there was a very quick feedback from the business community, the organizations could take a direction whether they had to continue and they were going in the right direction, or they had to pivot and move to something else. And what DevOps does on top of it is, DevOps says that bring in the ops guys as well very early into the life cycle, so that you understand the nuances of operations really well. So say, for example, if says today you guys were writing some code, and so you were discussing the architecture, and the ops guys are involved in some of those discussions, then they can give you the perspective of the performance side of things, the alerting side of things, the monitoring side of things, and likewise. And hence, when you design that architecture, it will become more robust because now it has also constituted and considered some of the elements that a production that would have been seen from a production lens. And hence the involvement of dev guys to understand more of the ops world, and vice versa, by the way, the ops guys to understand more of how the development guys work. All that becomes pretty easy, and it becomes seamless then, because then there is no handoff. So for example, in the earlier days, how it would work is that you get a requirement, and once everything is tested, coded, you ship it off to the ops guys, and then the development guys sit at peace and at leisure. No work. Let's see, whatever fix comes, it's the responsibility of ops guys. No, that takes a very long time, because the ops guys were not involved early. They have to look through some documentation and understand what you've done, or maybe reach out to you. So those nuances have gone away with the DevOps world, and the ops guys understand the way the development is writing the code. They understand the kind of measures that are being brought upon, the design patterns that the dev guys are introducing, and likewise the dev guys understand more things from an ops perspective and make sure that the code that they write, it constitutes some of these elements. So again, I think a lot of you guys practice the extreme programming. I don't know if you practice, but you should look at solid programming principles. So SOLID, solid is an acronym, and when you are looking at object-oriented languages like Java or C++ or some of the other languages that you may be using, try and see if you can practice some of these elements of solid in them, and that will help in making sure that you understand a lot of these dimensions on what are the right kind of practices I can bring into my code. So all in all, the message that I wanted to give here is that there were methodologies that were existing earlier, like waterfall, which was very predominant, but now the agile has taken over, and DevOps and agile go hand in hand, where the idea is that the dev and ops work together, and then they release things into production. In fact, so much so that within the industry, there is a thin layer of operations team existing. So earlier, when I was, say 10 years back, we used to have an army of operations guys, 200, 300 of them, trying to support, multiple areas within the operation, alerting, logging, monitoring, and stuff like that. But within the industry now, what is happening is that a lot of these operations guys are becoming part of the feature teams, or they are becoming part of the application teams, because then they can independently work and release things all the way till production. So in a lot of organizations, operations has become pretty thin, where they take care of things like access management, access elevation, security, and some of those areas. So these are some of the big changes that are happening in the industry, and hence people in the DevOps world have to be cognizant of what is happening on the dev and test side of things, and also on the operation side of things. Okay, so what is the summary? So summary is very simple. You have the dev and ops working together. The dev, which is trying to introduce more speed and making sure that the changes are getting into production, and ops are wanting to look at stability within production. So dev and ops, when they work together and ensure that the changes are released faster to production, and at the same time they are stable enough in production, so that you have a reduced time to market, which means that you are releasing very quickly to the market, and you get a quick business value realization. So how will you realize the value when something hits market? So you have a new feature, and that feature goes and hits the market, and the market picks your feature up. The people, end user or the customer, likes it, and then you get more business, right? So you gain profit out of it. So this, in a nutshell, is why and what of DevOps. And I'll give you a very small example. In fact, you can read some of these books. So we have a very nice book written by Eric Rice. I don't remember the year. I think it was 2003, but it was about a build, measure, learn cycle, and that's something that most of us have followed. So what happened is that he wanted to release a software where you could download the emoticons, and it took him around 6-7 months, and things were still not stable. And after 7-8 months, when it got released, then finally, nobody ever downloaded it. So this entire effort of 7-8 months, it just became kind of zero. And that is where he realized that what he could have possibly done is he should have first understood what the pulse was from the market. So the easiest thing he could have done is created a web page where he could have just given the emoticons. It would have been a simple HTML, plain flat HTML. But at least if he would have seen that, I have 20 hits, 30 hits per day, then there is enough interest in building something further. And then he could have taken that as a prototype and then developed. So this was a kind of a lesson learned for him, where he said, instead of releasing in a big bang 6-10 month of an approach, where something when hits production, the end customer says, well, it is no good and nobody uses it. Instead of that, let's try and gauge the customer pulse by making a smaller release, seeing that the features are getting adopted in market and people like it, and then building something further upon it. So making sure that we move a lot faster and making sure that we are stable enough in production, and hence we realize the business value a lot more quickly. So that in a nutshell is the what of DevOps. So let's now move on to the how part of it. So we have understood the key trends in the industry. We have understood why enterprise agility is so important, and in bringing that enterprise agility, why did we need DevOps, what DevOps is all about, and what were the key pillars or constituents of DevOps. We have discussed that. Now, how do you do DevOps? Let's try and unravel that. So for that, let's try and understand some of these terms. I'm sure some of you guys would have read through it or heard about it, but let me try and explain it so that everybody is on the same page. So continuous integration. Continuous integration is not just about the build. So continuous integration is a process where you build and at the same time you unit test your code, and at the same time you run the vulnerabilities on your code and see if there are no issues with regards to the quality and security, and you make sure that you have enough code coverage in your code. And if all looks good, then and by the way, your build should not take forever. It should not take like maybe whatever, say 40 minutes. It should get completed within 10 minutes. And there are a lot of techniques on how you can make sure that your build doesn't take a long time. And once the feedback goes to the developer, whether it is in case of, let's say, a reduced code coverage, or it is in terms of, for example, the unit tests are failing, or if it is in terms of the vulnerabilities that his code has introduced, or maybe even a build failure, if the response goes immediately to the developer, then this process is what we call as continuous integration. So you are bringing in some of these elements within the build, and you're continuously integrating them, and then you provide a very quick feedback to the developer on some of these aspects, whether his build has passed or failed. Let's assume that the build has passed, but after that, has he or she written enough unit tests so that the code coverage is okay, and then running the vulnerability tests on the code that he has written. Is it not vulnerable? If all looks good and the developer gets a quick feedback within 10 minutes, that process is known as continuous integration. And of course, there are multiple tools that help you do so. So Jenkins is one such tool, because a lot of times when we talk about continuous integration, people say continuous integration, it means Jenkins. It doesn't mean Jenkins. Jenkins is one part of the story that helps you in doing continuous integration, but there are multiple elements like we talked about. Continuous delivery and continuous deployment. So these are two terms that should not be used interchangeably. There is a significant difference between them. So continuous delivery, let me try and take continuous deployment, because you guys will understand it a lot faster, because you guys are on Instagrams and Facebooks and stuff like that. And well, possibly I don't have a Facebook account. So continuous deployment means that as soon as you write the code, there are various checks that happen. But after all those checks, it goes and hits production, and everything is automated. There is absolutely no human intervention there. So you write your code base, you commit, and certain tests and checks will run, and it will pass through various environments. Your development environment, then it goes to your test environment, then it goes to your user acceptance testing environment. It'll go to a pre-production environment and a production environment, just at the click of a button. And in all of these cases, whether you talk about vulnerability tests, you talk about your stress tests, you talk about your regression tests, all of that is automated, and they are all part of the pipelines. So this is what Facebook does. So if they have to release a feature, they follow the process of continuous deployment. Continuous delivery means that you still have an automated pipeline, and you still have made sure that up till your user acceptance environment, the code base has reached in an automated fashion. You still have the facility where you can deploy it automatically to production, but you will wait for the business to give a go ahead. So once your people who are on the ground and people who are part of the business community, once they say that, okay, now let's release it to production, then the production release happens. Or in some cases, what happens is, even though the feature is released in production, but it is still not available for live customers. And again, there is a on-off switch that can happen. So say you develop a small snippet, and the snippet goes and sits into production, but it is still not made live to the end customer. And once that on-off switch, which is managed by config files, and there are various techniques to do so, once you turn them on, because the business has given you a go ahead, then the feature becomes live. So in organizations where they want to do multiple deployments in a day, so like for example, Facebook, they follow the continuous deployment strategy. A lot of our clients, where they do not look for multiple deployments in a day, they will go for a continuous delivery strategy where the client is still fully prepared to go and hit production, but only when the business says yes, that is where they will deploy it to production. So those are the nuances of the two terms, and they should not be used interchangeably. Okay, so we talk about the components of DevOps, and so typically what you see below is what we call as a pipeline. And of course, I have not written tools because the tools keep changing every day. So the idea is that you get requirements, then you do your build, you have your testing, you do a deployment, you have operations, and then finally you do an optimization. And in each of these, we have various set of tools. So you have certain tools where you put in your requirements. So some of the common ones that we utilize today are, like, for example, Confluence, or if you're looking at, let's say, Microsoft, you use things like Azure Board and all. And tools like Jira, very, very popular in market today. Then for building, again, you utilize Maven, Gradle, those kind of tools. And I'm sure you guys would have used some of this. For people who were coding in the Java world, for example, you would have used Maven, and likewise multiple tools again. And then for testing, again, multiple tools available. So we utilize a lot, tools like SOAP UI. Again, from an open source perspective, there are multiple tools available that can be used. And similarly, when you do a release, or you deploy to production or to your various environments, you have, again, tools available. And similarly, from an operations perspective, tools like ServiceNow, where people can raise their requests. You have monitoring tools, multiple of them available. In fact, again, we have a lot of focus on tools like ELK, or or some of the commercial ones as well, on cloud, like New Relic and all. And finally, you do an optimization. So the idea is that in this cycle that you see, I have just tried to do a bit of a classification of agile, continuous integration, continuous deployment, delivery versus DevOps. So the idea is DevOps is an overarching umbrella. Again, keeping all those 4 pillars in mind, we have to make sure that from requirements till release and operations and finally optimization, everything comes under the DevOps umbrella. Okay, so let's talk a bit about these aspects where we call agile development, continuous integration, and continuous deployment and delivery. So agile development we covered in bits and pieces and in flavor, but essentially the idea is that we take up requirements that are small enough and we break them down into what we call as the user stories. And each user story is something that is tangible and can be put to where you can close off the development, let's say in 2 days. You test it in the sprints that you design. So sprint is nothing but a duration. So generally we have sprint durations fixed between 1 week to 2 weeks. And in that sprint, you have to complete all the activities. And when I say all the activities, you have to make sure that you complete your development, you complete your testing, and the feature is showcased to your business. And then there is a go ahead or a no go ahead, depending on the output that you produce. Now, continuous integration, like I said, this process has a lot of gates, and we call them as gated mechanism. So it is not that you just build your code and you start deploying it, right? It has to undergo certain checks and balances. So check and balance on quality. How good is your code? Have you followed the right rigor in writing the code, in the best practices on the code and things like that? Then your code is checked for security vulnerabilities. Your code is checked for performance and how it is giving on the performance parameters. And if all looks good, and if the functionality is passing through as well, then it is going ahead and hitting the production. So again, we've talked about continuous integration. I don't want to emphasize more on it, but the idea was that the deployment artifact, before it becomes a good candidate to go into production, it has to go through certain checks and balances, which is the part of that continuous integration process. Continuous deployment and delivery we've covered, and so I'll not emphasize much on it, but the objective is that the word continuous here means that the changes are happening at a very, very regular frequency. So I do a commit to my code base, a number of checks they will run on the code base that I commit, and if all the checks are passed, I get a good deployment candidate, and that deployment candidate that goes into various environments like dev, test, whatever, user acceptance testing, pre-production. People also have performance environments as well, and in each of those environments there are acceptance tests, and all of them automated, right? So that is the idea across the continuous deployment and delivery. So this in a nutshell was the overall DevOps cycle from a code perspective. So how does the code move? You check in your code, then you pull the changes, you pull the code changes for your build, you run a number of tests on them, and if all looks good, you store the artifact. That is where some of these tools that you would have heard, like Nexus or Artifactory, they come into picture, where once you get a good deployment candidate, it actually goes and sits in something like a Nexus or an Artifactory. And then your CI/CD pipeline will pick it up from that Artifactory and then goes ahead and does a release to various environments. So this is an overall constituent of a DevOps cycle. And I will again encourage you guys to take a look at some of the CI/CD pipelines that you can form, either let's say on AWS, or maybe you can create your own account on AWS and try and practice on, say, code commit, code build, code pipeline, some of the native services that AWS provides. Similarly, in the Azure world, you have the Azure DevOps, and you can practice some of that on Azure. Again, you can create your free accounts, and you guys can try that. So what will happen is it will give you the pulse and the feel of how the execution of your code base actually happens. It's not just about writing code anymore. It's about making sure that you write code which is of enough quality, and it has to pass through the rigor of the pipeline. Okay, so this is extremely important when you guys move to organizations where you think you may be following the best practices, but at times you figure out that certain things are failing, and hence you should have incorporated some of these factors more. All right, so let's talk about how enterprises run DevOps initiatives. And why this topic is important again is because when you guys become part of the organizations, and so let's assume you're part of certain teams, you have to make sure that it is not only about the work that you get and you deliver, but there are larger constructs that you have to keep in mind, and that is where it is very important for us to understand how enterprises are running these DevOps initiatives today, what it means for them. And it is always good to have that end-to-end picture, because what happens is, then you become a lot more attached to the work that you deliver. It looks a lot more tangible to you, and which is why it is important to get the larger picture. So how enterprises run some of these initiatives. So the heading reads, how do organizations run DevOps transformations? Let's understand what transformation means. So transformation is a journey. So like I said, within the organizations, they will always start with a problem. So let's assume the problem is that I do, let's say, 3 enterprise releases in a year, and whereas my competitor is releasing features every month, and hence they are gaining more eyeballs, and I need to do something about it. So that's a problem that the business community identifies, and then there is a discussion. Business and IT sit together, and they decide that adopting DevOps is one such lever that can help them move faster to production, and making sure that their enterprise release cycles that were 3 or 4 months long, they get cut down. So they are releasing, the time to market is coming down, which means they are releasing faster to market. So in that case, DevOps is a lever that they think they are going to apply. Now what happens? So the organization has taken a decision that they have to move towards DevOps. What they have to do is, so first they have to ensure that they set up the right teams, they set up enough tooling, they bring in enough process angle. So we talked about agile, right? So let's assume that this organization did not have enough agile, or it was being done in pockets. So you bring in the best breed processes, and then you equip your people again, because not a lot of people may understand. For example, a pipeline gets stitched, but how do people understand the nuances of a pipeline? Or for example, certain people have been used to working in the waterfall ways, and now they have to shift their thinking when they move towards the agile ways of working and things like that. And the organization itself has to change its ethos or the underlying culture. So for example, when you do a hiring, and so I'm looking at functions which are beyond IT as well, your the way your HR functions, the way your funding happens, a lot of these constructs will change. So transformation is a journey for an organization where they consider people, process, culture, and tooling all together, and they identify interventions in each one of them and what it takes to take them to the next level, where they become a DevOps. They start adopting the DevOps ways of working. So like I said, for example, let's say that an organization is looking to get in people, and when I say people, as in they could be people from the business world, they could be people from the ops world, there could be people from the testing community. So when they hire such people, maybe they will have, say, a half day or a 1 day session on DevOps, and give them the understanding and nuances that our world is changing, and hence each of these entities need to adopt DevOps. So those are likewise, there are multiple changes that happen in an organization. So transformation is somewhere between a 1 year to a 2 year journey for a lot of clients, where they make sure that they go on a higher maturity curve on people, process, culture, and tooling, and then reap the true benefits of DevOps. So what does that journey look like, and why it is important for us to know this journey? I'll explain in a minute. So first thing is your organization ready? So from a DevOps perspective, there has to be a top-down approach, of course. And everybody should be ready mentally that they have to move into this newer world. So that is a very, very important constituent, because otherwise if your leader has a different view, then it doesn't, then the right messages are not percolating down. The second is the analysis of your landscape. So let's assume the organization is ready. Well, right from the business community to the dev test to the ops, everybody is ready to embrace DevOps. Then they analyze their landscape and find out what are the good candidates for DevOps. So, for example, if I was an organization and I had certain legacy systems where I was only changing code base, let's say twice a year. So if you're not making frequent changes to production daily in systems, then they are not the good candidates for DevOps, right? Why would you want to build a platform for them that helps them in delivering faster? They don't need to deliver faster, and that's the business need. So you have to analyze your landscape and understand what are the good candidates for moving to the DevOps world. And you create a blueprint, and this is a very important term, blueprint. And once you guys are part of the industry, you will keep hearing this term quite often. So blueprint essentially will have the opportunities identified in each of these four pillars, like I said: people, process, culture, and tooling, and whatever it takes for us to make sure that those gaps are all out of the picture. So we have to make sure that if there were gaps in terms of getting new tools, we get and procure them. If there were gaps in getting the right skill set, then we do that as well, and likewise. And then you set up the capability and the governance, which means that now that you've decided and finalized on things, you've set up these capabilities and you bring in a governance layer, because everything has to have the governance on top of it. And then you build your automation, bring in certain pilot candidates. If the pilots candidates work, then you do a rollout, and then that rollout is on at a scale. So this is how the organizations they go on their journey for transformation. So why it is important for us to know this is because when we become part of such organizations, we have to understand this end to end, and we will be involved in a lot of such stages. So for example, you may still be joining as a developer, but you may be asked to, let's say, do a gap analysis and understand what it takes for us to, let's say, build a CI/CD pipeline, and whether we have enough constituents to build. So today, do we have the knowledge in some of these tools or not? And if not, then your organization will help you bridge that gap. So a lot of us will be involved in these stages, which is where it is important to know what an end-to-end transformation for your clients or for your organizations will look like. Then let's talk about the key factors. So that helps us in succeeding in this DevOps transformation. So like I've already talked about, your senior management, your stakeholders, they should know what they are getting into. They should be fully convinced about it. And you do measure what you are building, and we'll get to it in a minute. If you are not getting enough results, then you pivot, which means that you course correct yourself and take whatever is the next best direction for you. And should always be a study of the business impact of such an initiative. So you launched a DevOps initiative, you are going to spend millions of dollars on it, maybe when it comes to maybe training and coaching of people, or getting new set of tools, or bringing in some coaches and experts and things like that. So you should always first have a very, very good handle of what is it going to give me in return. And how do you measure the impact of DevOps? Is by two things. So let's assume that I start a DevOps intervention today, and I'm targeting, let's say, 50 applications in 6 months of time. So I do a baseline of two things today. We've kept talking about it all the while, right? We've talked about speed. We've talked about resilience in production. So if I am able to release a lot faster to production after I've undertaken the DevOps journey, and my production incidents or the severity one incidents that are happening have actually remained the same or have come down, then I have made sure that I have followed on the right journey of DevOps. And these are some of the metrics. Of course, when there are a lot many other ways to measure whether your engineering quality has improved and things like that. But from a business perspective, so let's say if I was pumping money into a DevOps transformation, and if I was a CIO, I would look at if my applications are deploying more frequently to production, and so what is their deployment cadence and deployment success rate, and at the same time, have they been stable enough in production? And if so, then I am good. Then I've vested my money in the right place. Okay, so what we have done so far, we have talked about we've talked about the why, we've talked about the what, we've talked about the how, and then we've talked about how enterprises embrace the DevOps journey. And it is a very important constituent for us to measure this journey. And how do you measure? By bringing in some of these metrics, like we've talked about, speed and resilience being one of the most important ones. Okay, so last 10 minutes, and what we will do is we will only talk about what is in it for you, right? So all this gyan and knowledge we have talked about all the while, but what is in it for you? So and how do you build in this capability? So the very first thing you have to ask yourself is, where is your heart in this? Okay, so if you relate to something like this, if you have a passion to learn new tools, so believe me, DevOps is a very, very rapidly evolving market. So today I have a tool, 6 months down the lane, there is a new tool in the market. So if you have that passion to continue to learn about new tools, the new features, if you have passion to automate certain things, so how the DevOps movement has started is very simple. So one fine day, some developer who was doing the same routine manual task every day, he sat down and he said, no more same task, I am going to automate it. So if you have that passion to continue to automate things, then this is the right place for you. So the very first thing is, understand if you want to be into this space, then you have to make sure that you continue to learn and unlearn as well, by the way. And so that's the second point. It is not about the tools at all only, it's also about the processes. So there are many areas from a process perspective that you may have to know as well, and you have to adapt. So it's both how well you adapt to the processes and the tools. And in a lot of cases, let's say you for example, I'll give you an example from the industry. So some time back, say 2 years back, a lot of us were coding using Java on Android, but then Google brought in Kotlin, and then we had to adjust and adapt on how Kotlin works and things like that. So at a very, very frequent basis, we have to continue and update ourselves. And then the third constituent is developing a T skill set. You will see some of these words quite often, either in the newspapers or blogs or articles that you read on DevOps. So just like the letter T, right? So you need to have breadth across a lot of topics. So we've talked about, say, people, process, culture, and tooling, right? So you should have breadth across a lot of them, and you should have depth in one of them. So for example, I pick up certain tooling sets. So I pick up, let's say, skill set on certain tools in CI/CD, and I'm very, very well versed with it. But that doesn't mean I'm completely oblivious to what's happening in the testing world or in the monitoring world. So T skill set is going to be extremely important. And of course, when you get into the industry, you will figure out that it's not about T. People talk about comb skill set. So you've seen, right? Comb has multiple layers, which means you have to be good at everything. And pi skill set, which means you should have, just like the letter pi, right? You should have depth in 2 areas and things like that. So don't get overwhelmed. The idea is very simple. You should have depth in one of the areas, whereas you cover the breadth across all the areas. So make sure that certain tooling that you know it really well, but you should also know about the people, process, culture angles. So we've talked about in that last point, right? Cover the breadth across all the 4 pillars: people, process, culture, and tooling. So the summary of it is that for something like DevOps, get a very, very clear understanding of DevOps first, which means that it is not only about tooling only, it is about these other dimensions as well. So let's be very, very clear in our heads what it is all about. And always keep a very, very close tab on whatever is coming in the market in terms of the latest. So prescribe yourselves to some of these tools, how the tools are evolving by themselves. So for example, 3 years back, these tools used to serve certain purpose, but now a lot of them are building in capabilities on AI and ML as well, so that you can see a lot of diagnostics coming out of these tools. So make sure that we keep a continuous. And by the way, this doesn't hold good for you. It holds as good for me as well. So we keep a very close tab on whatever latest that is coming in the market, and we continue to equip ourselves on some of these tools. Have a lot of sessions, knowledge sessions for people who know them, or look at webinars and things like that. And of course, getting certification, it's a good way to get a bit of a recognition that that you've done something in this field. And then, of course, last but not the least, go for it. So this, in a nutshell, is what I wanted to cover, and I hope it has been helpful.
Thank you, sir.
Thanks a lot. Thanks a lot for all your time. Are there any
So
queries
there
or
is
questions that you want?
yes, sir. There is
one question. Which are the top DevOps tools? And which is the project that needs to be implement using DevOps? How to approach the project?
Okay, great. So which are the top? So there are two questions that I see. How to approach a project? Yeah, very, very good questions, guys. So correct. Okay, so let me take both the questions one by one. So how to approach a project that needs to implement using DevOps? So the first thing you have to do is establish a need for DevOps. And what it means is that you have to judge the maturity of from a people, process, tooling, and culture angle for that particular team or the project. So when you judge the maturity, you will realize that there are certain gaps in all the 4 areas, and then you build so that the blueprint that you create will be across all the 4 areas, and then you supplement those 4 areas and make sure that you elevate the pitch on all the 4, and hence adopt DevOps. So for example, you have a project and the need comes to implement DevOps. Let's say this was a Java-based project. So the first thing you do is identify what are the right. So let's talk from a tooling perspective. So you will identify what are the good tools that are available in your landscape to make sure that you make a CI/CD implementation. So let's assume that today in your landscape you have Jenkins. You also have unit test frameworks that you can utilize like JUnit. You will have certain quality tools like, let's say, SonarQube, which you can bring in. You can bring in certain security vulnerability tools, and they may be commercial or open source depending on your organization. So what you do is, so once you identify, let's say, the gaps in tooling, and you say these are the 5 things I would need from a tooling perspective. Similarly, you will have to identify the gaps from a people perspective. How many of my people know these tools? Do I need to provide training to some of them so that they understand this a lot better? Then you have to make sure that you follow the right process. So you set up a process layer where you say that if I was having, let's say, a platform team that created the CI/CD platform, who is going to be the administrator, who controls what goes in. So let's say, for example, a tool like Jenkins, right? Anybody can go and take up a plugin in Jenkins and install, but then it may cause some other things to stop. So I need to build in a governance layer. So the point is that the first area to start is to judge the maturity on all these 4 dimensions for your project team. And when you identify the gaps in all the 4, then you start filling up those gaps and you produce a roadmap. So you say, first 2 months, I'm going to focus on tooling and make sure that my pipeline is robust enough. Meanwhile, I will train my people so that they understand these tools and how it all works together. And then you have to create a framework where you have to measure the metric as well. So you create that framework and you start pulling up data in terms of how many deployments you are making, how many times your deployment was successful, and things like that. So you have to cover this journey from all those 4 pillars. Now, what are the top DevOps tools? That's the second question. There is no end to it. So what you should do is, the landscape or the technologies that you deal with, focus only on them. So for example, most of you may be writing, let's say, code base in Java, Spring Boot. You may be writing code base in .NET. So for .NET, for example, you may start utilizing, let's say, pipelines within the Azure world. So you have Azure DevOps, for example. So see if you can create an end-to-end pipeline for .NET and let's say do a deployment in something like, let's say, an Azure Kubernetes service. So Kubernetes, Docker, containerization, you guys would be keeping hearing some of these terms a lot, right? So maybe that's a small experiment you can do if you like the .NET world. If you are in a Java Spring Boot world, for example, and let's assume you were familiar with AWS, again, go and create a free tier in AWS and see how you can stitch up a pipeline where your Java Spring Boot code gets picked up by, you can do a code commit in AWS code commit. Then you have a pipeline that gets built up with AWS code build, and then you have those constituents within your AWS code pipeline as well. You run certain health checks, and I say health checks as in certain quality and security tools, and then similarly you do a deployment of that application by containerizing it and putting it into EKS. So there are a number of tools in the market, and make sure that first you have a good visibility on what is that pipeline that you want to create, what elements will constitute the pipeline. Go for some of those open source tools, stitch them all together. In fact, a lot of people have developed pipelines using Jenkins as well, which is a very good start, I would say, to understand how all of these things work together, and then you can utilize some of these tools in the market. I hope that helps answer the question. Are there any other questions? I think those are the only ones that I saw.
Only those, sir.
Only 2 questions, sir.
Only 2
one
questions.
more.
Okay.
One more.
Yeah.
Which all industries are using DevOps?
There is no industry that is not using DevOps today. Let me answer that. So what used to happen is, say, 5-10 years back, the industries that were very, very regulated, like healthcare, pharma, aero industries, they were kind of averse to DevOps because DevOps and Agile said that deploy more frequently to production, right? And they wanted to see stability. So for example, you see in how many years you launch an aircraft, for example, right? It's a very different model than how you release, let's say, a software to Facebook every day. But now what is happening is that even there is enormous amount of competition coming in to release the features faster. Let's take the case of COVID, for example. Everybody is behind doing quick testing of the vaccine and releasing it as quickly because they want to grab the market share. But at the same time, I just cannot release a vaccine today. It may work, but after 6 months, it may cause blood cancer. You never know, right? So I have to make sure that I test some of those things as well in this whole journey. So even when you talk about these pharma companies that are trying to build, whether it is vaccines or something else that is coming to market, they are all getting onto the DevOps journey where they are able to test something really quick and make sure that it is resilient enough. At the same time, they are able to deploy this very, very quickly to market. Okay, so there's a very interesting question. Are Agile and DevOps the same? So they are not the same, but they go hand in hand. So what it means is that you cannot have an Agile only flavor without DevOps, because then you do not get the true benefits out of it. So Agile and DevOps go hand in hand. Agile has multiple flavors on how you can execute. I don't want to get into the nuances of it, but there are multiple frameworks available for organizations to adopt, most famous being Scrum. And what DevOps does is complements by bringing the DevOps business, all that angle together, so that when it combines with Agile, it's like, you combine the two things together so that this moves a lot faster. It's something like that. Okay, any other questions?
No.
That's all.
Okay, great. So if there are any further questions, then you guys can send it to me at my Gmail ID. It is adarsh12in@gmail.com. So let me pull it up in a minute and show it to you. and that's my phone number and my LinkedIn account as well. So at any point of time, if there are any queries on DevOps, feel free to reach out to me. And yeah, and I hope this was helpful.
Yes, sir.
Okay, great. So thanks a lot again for the opportunity, and yeah, and hope to see some of you guys working on DevOps and getting hooked onto it.
Sure.
Sure, sir.
Have a nice day, everyone. Take care. Bye.
Thank you, sir, for sharing your valuable knowledge and sparing your time with us. And today you have that is explored on why, what, and how of DevOps and journey of DevOps and measuring the DevOps and building DevOps competency. Thank you so much, sir. It was very informative. Hope all the participants have greatly benefited out of this webinar. Thank you so much, sir.
Thanks a
I
lot.
I request Professor Suresh Kumar to propose a vote of thanks.
So, good afternoon, one and all. I, S. Suresh Kumar, Assistant Professor, Department of CAC, Vivekananda Institute of Technology, who take this opportunity to express a vote of thanks. It's my privilege and honor to express my gratitude. First, I thank our management, Janta Education Society, for their support. I extend my immense gratitude to today's speaker, Mr. Adarsh Mehrotra, Industry Principal Consultant at Infosys, for sharing time for us in his busy schedule to share the knowledge. Thank you, sir.
Thank you.
I express my immense pleasure to thank our Principal, Dr. Kumar Kentegoda, sir, and Vice Principal, Dr. D.V. Chandrasekhar, sir, for their support in successful conduction of this webinar. Thank you, sir. I also extend my heartful thanks to our beloved HOD, Dr. Vidya A, Professor and N, Department of CAC, for her continuous support in conducting webinar like this. Thank you, ma'am. I also thank HODs of all departments for their support and involvement. Last but not the least, I thank teaching and non-teaching staff of our department and all the participants for their active participation. Thank you one and all. Stay home, stay safe. Thank you, sir.
Thank you. Thank you. Have a nice day, all of you. Bye.
Thank you.